So we continue on with our example of an ellipse that has a center. We don't know. We find the center and the endpoints of the minor axis. We know the vertices are at -1, -3, and -1, 5. And the foci are at -1, -1, and -1, 3. So I would start by just having a look at what that is going to look like. So let's look at -1, -3, and then -1, 5. All right, so we can tell right away that this is going to be vertical because the vertices are always on the major axis. And we know that the midpoint of those two has to be the center. So to find the center, we know it's going to be -1, and then -3 plus 5 over 2 for the midpoint, and that would be -1, 1 for the center. Of course, you could probably count it off too. All right, and then we have center. We know A then. If we have, that's -1, 1, so we just count, and we see that A is 4. And then we know the foci are at -1, -1, and -1, 3. So we can also just count off and see that C is 2. And we know the relationship C squared equals A squared minus B squared. So 2 squared equals 4 squared minus B squared. So -12 equals -B squared, or B squared equals 12. So B is plus or minus the square root of 12, which is 2 square root 3. You can leave it the square root 12 if you like. All right, and then we have, where would that be? Well, we know it's got to go left and right because that would be how the part that's missing on the minor axis. So we just go from the center, -1 plus or minus 2 square root of 3, 1, and those are the endpoints of the minor axis. All right. Now, so all we need, we've got the center, endpoints, and we need the equation. So we have the center and A and B, so we have everything we need. So we just put it in the right format, x minus h squared over b squared plus y minus k squared over a squared equals 1, and we fill in what we have. So we have x plus 1 squared over b squared was 12 plus y minus 1 squared over a squared was 16 equals 1, and we have all three things we've been asked to find. Sometimes you'll have to find the standard equation from by completing the square. So for this one, let's work on completing the square. First, what we'll do is we will group the like terms and move the constant. So group the like terms, so the x's together and the y's together. 9x squared minus 18x plus 4y squared plus 16y, and move the constant over to the other side equals 11. Now you're going to factor out the coefficients of the squares. So the coefficient of x squared is 9, so you're going to factor out a 9. 9 times x squared minus 2x, just for the x's. And then for the y squared, we have a 4, so we factor a 4 out of the y's. Y squared plus 4y equals 11. Now we're going to complete the squares on the inside of the parentheses. So we do half of the xy term, x or the y term, squared and added. So what's half of -2? That'd be -1 squared plus 1. And half of 4 is 2 squared is plus 4. Now we're often tempted to just write plus 1 and plus 4 over here with the 11, but you gotta look carefully. You really added 9 because you added 9 times 1. So we have to add 9, and here we really added 16, so we have to add 16. So now we condense, and we have 9 times x minus 1 squared plus 4 times y plus 2 squared equals, if I did this right, we get 36. Very good. Now it's like the problem we had earlier, divide by 36, and you get x minus 1 squared over 4 plus y plus 2 squared over 9 equals 1, and it's in its right format. Okay? Sometimes they'll give us a picture of an ellipse that's not centered at 0, 0, which is pretty easy to figure out where it's centered. There's its center, so we write down the center to -1, and then we just count off. The A is 4, and the B is 2. So we have A is 4 and B is 2, and it's horizontal. So we have x minus 2 squared over 4 squared plus y plus 1 squared over 2 squared equals 1. Nice and fast, easy to do. Applications. Now there are several applications for ellipses. Elliptical orbits, a whispering gallery or whispering dome, and then also disintegrating kidney stones. We use ellipses as well. All right, so in the resort hotel in Disney World, there's an elliptical dome. It's 40 feet wide by 10 feet tall. And if you stand at the foci, you can whisper, and the person across the room can hear you. So the question is, how far from the center do we have to stand? Well, let's fill in the equation of an ellipse. Because it doesn't say a center, I like to say the center is at 0, 0. So that makes the A be 20 feet, and our B is 10. All right, so we have x squared over 20 squared plus y squared over 10 squared equals 1. And then, of course, we want the foci, so that's c squared equals a squared minus b squared, or 20 squared minus 10 squared, which is 400 minus 100, so 300. So c is the square root of 300, and that is 17.3 feet from center, if my calculator's working right. Okay? All right, and then our last one is about elliptical orbits. So the moon is traveling around the Earth in an elliptical orbit. The Earth is at a foci. The major axis and the minor axis are 768,806 and 767,746. Okay? Find the greatest and least distances from the orbit to the Earth's center. Okay, so apogee is the greatest distance, and that's A plus C. And perigee is the shortest distance, and that's A minus C. All right, so we know the orbit, we know the axes. So what's A? Well, half of that axis. So half of that is 384,403. And then B is half of the minor axis, which is 383,873. All right, so we have A and B. But in order to find apogee and perigee, we need C. So you all know what we do. C squared equals A squared minus B squared. So I'm just going to write these numbers. I'm going to let the calculator do the heavy lifting here. I'm not going to actually do all this squaring out. 384,403 squared minus 383,873 squared. And then I want the square root of that. So I'm going to let the calculator do that all at once. C is equal to, thank you calculator, 20179, 20,179. And then apogee, I'm going to add that, A plus C. And I'm going to get 404,582 kilometers. And then that's apogee. And then A minus C is going to be 364,224 kilometers. And that's perigee. All right. So have fun with ellipses.